Hello, hello everyone. Can you hear me, guys?
Yes, sir.
Okay, let me share my screen. Can see, right? Okay. So last class we have started with abstract class. Okay, we have seen what is abstract keyword, where we can use it, and what is the meaning of abstract keyword. When a class is abstract, we can define all the members, but we cannot instantiate. Abstract method means we cannot define the body, we can just define the signature. Okay, so coming to next 156 55 dot java. So now say class A, which is abstract class A, and it will have one method void m. No argument, no implementation, and because it is no method, so it should be abstract method, right? And suppose it has a void show method which is implemented, not abstract, and then say show method in a class, right? Now static method, if the method is static, we can call it the class name, but it is an instance method. So to call that, we need to create an object, and we cannot instantiate because the class is because it has a class is abstract and it has abstract method. So what we have to do to instantiate, we need to subclass it. So class B extends A. Okay, when class B extends A, that means all these properties inherited to B. Now B class is having an abstract method, right? This inherited one. So what you have to do, if you compile this like this only, it will be an error. And what will be the error? The error will say class B is not abstract, but it has an abstract method M. So this inherited one, it will say. Okay, let us compile this and check once. Java C test 155.java. So this is B is not abstract and does not override the method M in A. This is inherited one, it is saying. Okay, so inherited method abstract is there, so class should be abstract. So if we declare this class abstract of no use, right, we are creating this class so we can instantiate and we can use those methods. So what you have to do, you must override this method and you have to give a body. Okay, you must override, and you can say here body implementation is this M method in B class, which is overridden. Okay, M method. So now B class is having two methods, M, which is inherited and overridden, and inherited show method also. And now no need to declare this class abstract because no abstract method in it. So what you understood from here is when a class is abstract, you cannot instantiate. So if it is having any method, or if you want to create the object of that class, you need to subclass it and then only you can instantiate. But when you are creating a subclass for that, abstract method must be implemented. Okay, you have to write the implementation for abstract method. Now if I compile this, now it is okay, no error. Right, that is fine. Now what we can do, through the B class, we can use the dynamic display was also no issue. Okay, reference variable you can create always new, but object should be of type B. Okay, now a1 dot m you can call, and a1 dot show also you can call. That m overridden one will be called, and show this one which is inherited. Compile test 155 and execute test 155.java. Not .java, you should not use .class file, .class. Okay, so this is done. Clear with this, right? Let us take another example. Test 156.java. So now assume I have two methods here as abstract, m1 and m2. Both is abstract. m1 and m2 both is abstract. Class B, which it is extending, it is implementing one method, but another remains as abstract only. Okay, another remains as abstract only. So now if I compile again 156, compile it 156.java. Okay, it is saying that, oh, not m, it is m1. Here it is giving the error. Compile again 156. Now it is saying B is not abstract and does not override M2. It is saying about M2. M1 is already implemented. The issue is with M2. Means M2 is still remains as abstract in the B class, which is inherited. So now what you have to do? Again, you B cannot instantiate. This statement will give error, right? First, this is giving an error. It is saying class B should be declared as abstract. So after creating subclass, if any method remains abstract which is not implemented, then subclass also should be declared as abstract. Okay, now again B cannot be instantiated. So what you have to do? Again, create another subclass for B. Class C extends B. Okay, multi-level inheritance. Now, how many abstract methods are there in B? Only one, which is M2 inherited. Okay, M1 was also inherited but implemented. Show is inherited, which is already having implementation, but only M2 remains unimplemented. So B we have declared as abstract. Now in C we will only implement M2. Okay, we will only implement M2 in C class. M2 in C class. And this is M1 in B class. Now it is complete. Now C class becomes concrete. Okay, A and B is abstract, incomplete. Now again, B and C we cannot, A and B we cannot instantiate. We need to create an object of C. Okay, now A1.M1, A1.M2, again dynamic dispatch concept will be used. Okay, now this should be fine. Compile test 156. Okay, where we missed that. C class extends. New uppercase C. Compile and execute. Test 156. Right. So this is how you will use the abstract class and abstract method. Next is, if abstract class cannot be instantiated, then why the constructor can be there? Take another example. Test 157.java. 157. And I'll not use this now. Simple class A. Okay, and which is abstract because I'll have abstract. Assume currently no abstract method, int x int y. Okay, and we can have constructor in it, int x int y, and this dot x is equal to x. I hope you remember the concept of this. This dot y is equal to y. I'll take another default constructor also, a, and this is default constructor. We'll write something. It is a default constructor. Okay. Similarly, one parameterized constructor is this one, so we'll write something here. A int and int argumented constructor. I'll use another one, which is one argumented. Say is like this. Just x. Through this, I'm not initializing y. So it is just int argumented and y is not initialized. So multiple three constructors, constructor overloading concept in class A, test 156, sorry, 157. If you compile, it works fine. It is okay. But what is the use of this constructor then? Because we cannot create any object, right? And what is the use of constructor? To create object. Abstract means you cannot instantiate, but constructors are allowed. Why it is so? Because you need to create subclass, right? Class B extends A. Now in B, you will have anyway one constructor by default. Let us implement that. B default constructor, right? And we are not implementing any, we are not having any abstract method in class A, so no need to implement. Just class B extends A and default constructor. We are writing it, so we can write some implementation in it. Now B class is a concrete class. If we instantiate B, that should be okay. B1, new B. Compile and execute. Test 57 and execute test 157. See the output. What it is doing? B default constructor, A default constructor. This is why, okay, this is why we can create constructor in abstract class, because you remember constructor chaining, right? And how it creates an object. We already discussed so many times for this. Let us remind that once again. Say we have one A class. As per our this example, this should be actually this way. And we have a B class. If we are not implementing anything, then B has a default constructor by default. And in this first statement is super. You know that. A has a default constructor by default. First statement is super. And what is the default superclass of A? Any class default superclass is object class always. Object. Okay. If you are not having any superclass for a class, by default superclass is object class. An object class is also having a default constructor by default. Now assume A is abstract and we cannot instantiate, but B is not abstract. It is a concrete class. And we are instantiating B. B1 is new B. When you call this constructor, it has super. It has to go to the this, which is abstract. Okay. And from here again, it goes to super, which is object. So it comes here. Because of this reason, this is how it calls, right? Object, I mean, the constructor call is like this when you are creating the object that we have discussed already. We have repeated a couple of times. So when you are instantiating a subclass, because of subclass first statement super, it has to call the superclass default constructor. And because of this reason, in abstract class, constructors are allowed. Okay. You don't think that constructors are allowed, so we can instantiate abstract class. No. Constructors are allowed in abstract class so that we can create the object of subclass. Okay. By default, it is calling the default constructor. If we pass here two parameters, say 10 and 99, Now where it will go? It will come into this one. From here, chaining, if we use X, sorry, this keyword you have to use, and this means it is calling this constructor. From here, first statement again, this means it is coming into default constructor. Default constructor by default, first statement is super. Okay, so now all the constructors, we are creating the object of B class using default constructor, but from here super class 2 parameterized constructor, we are calling this one. From here we are calling this one. From here we are calling in this. From here it is going to object class. So the output should be, when it comes back, first statement a default constructor, a int argumented constructor, a int constructor, B default constructor, then you get the object. Compile it. And execute. Test 157. Okay, this is the output. Right. So this is abstract class. You remember another important point again, I'll recall that abstract class can have implemented method also. Okay, abstract class can have implemented method, but when any method is abstract in a class, that class must be declared as abstract. Okay, but an abstract class may or may not have abstract method. It can have some implemented method, some abstract method. Why this abstract concept is required? The reason is, suppose when you are working in a team, you need to design a class. Okay, suppose you need to design a class, some person class. Okay, and in this person class, some implementation, some function implementation, say show info. You know the show info, you know the implementation, so you will write here. Okay, then you have disp, you know the implementation. But assume you have a function like this, get info. Get info is connecting to a database, and getting the data from the database. You don't know the connection and all the information you don't have. So what you will do, this function show you will implement, this you will implement, get info you will keep as abstract. Okay, so this can be one requirement. Now whoever is going to use this person class, they have to subclass it, and these two function implementation remains your implementation only, but get info they need to update, they need to implement according to their requirement. What can be the requirement? The requirement can be, it is maybe connecting with Oracle database. For some person maybe connecting with MySQL database. For some maybe in Postgres. Okay, so this part is not known yet. In that case of scenario, you can declare this person class as abstract. Okay, this person class as abstract. Or this can be one requirement. Another can be, suppose you are working in a team and you are the team lead. Some persons are going to design class. Say 2-3 persons are going to create one class. Class A, one person. Class B, one. Class C, some person. Three team member. One is going to design A class, one is B class, one is C class. But for all of them, one functionality should be common. You can tell them that for all of them, you can tell them that in your class, you should have a method do. It has to do some particular task. You must write a method with the name do, and it has these sets of parameters. All 3 person, whoever designing these 3 class, has to write this function do, and it has to have this type of signature. You are telling about the signature. This must be the signature in your class. So every time going to them, explaining, discussing, making understand, all this is difficult. So what you will do, you will have a template, set TMP, and that is abstract. And inside this, you will do signature, you will design. And you will say, whoever is creating A, B, and C, they must extend this temp. They must extend temp. They must extend temp. In this case, all these three persons must have to implement this do functionality in their class. Otherwise, their class will not be concrete. Okay. So this can be another requirement where you need to use abstract class or abstract function. You remember all the members what we have discussed so far: variables, static, instance, method, blocks, everything's are allowed inside the abstract class. Any question? No question, right? Okay, if no question, then next we'll come to the next concept. Interface. Interfaces. What is interface? If you remember the concept of language fundamental, there we have discussed data types, modifiers based on scope. Okay, primitive data type, these are primitive data types we have. User defined data type, where is that user defined data type? This data types in Java, 8 primitive data types. Apart from that, 4 user defined data types. Okay, in that one was class, and class is a template or user defined data type. So far we have discussed whatever members, classes, everything, template and all, right? Next is interface, user defined data type. Next user defined data type is interface, similar like class only. So this is interface. Now come back. What is the syntax? Syntax for class we have seen, right, already. Modifier, then class keyword, then class name, a block like this, and in that members of the class. And members we have seen variables, constructors, blocks, and methods, right? Apart from that, no other members in the class. Similarly, for interface, only thing is this, and you have to use interface keyword. Okay, you have to use interface keyword. Now, members. What are the members in class we have seen? You can declare variables, blocks, constructors, and methods. One more thing, you can have another class that is called inner class. Okay, we have not discussed yet, we'll discuss. So these are the members inside the class, but in interface, not like this. In interface, you can declare variables that will be by default public, static, final, and you know the use of these three. Okay, public, static, and final. What is the meaning? You know that You cannot use block, not there. You cannot use constructor, not there. You can use method, but that will be by default abstract. You can use inner classes, but those will be by default static. And here inner classes can be static, instance, and local, anything, okay? But here will be inner classes by default static. So by default, public static and final variable. By default, public abstract method. By default, static inner classes. Sorry, by default, public and abstract method. Public means, you know, anywhere you can use. Right. So these are the members can be used inside a inner class. Now, sorry, interface, inside an interface. You cannot use any constructor, okay? No constructor, no blocks. Variables you can declare, but those will be by default public, static, and final. Methods will be there, but that will be public and abstract. Inner classes you can use, that will be by default static. Okay, how we will prove it? Let us come with the variable first, okay? Test 158 dot Java 158. So assume lowercase. It is a keyword, okay? Interface is a keyword. All the keywords are in lowercase in Java. Interface in. This is the interface. And suppose before interface, let us take a class A, and in class A, public static final int x. You can have a variable like this, right? Public static final int x. Now if I compile this, no use, okay? We are not doing anything here, not using at all. Now you will compile, you will get an error, and you know why this error is 158. Test 158.java. It is saying that variable x is not initialized in default constructor, that we have already discussed. If a variable declared as final, it must be initialized in constructor or in blocks or in the same statement. We have already discussed that in class, okay? So if the variable is final, it must be initialized either in the same statement or in a block or inside the constructor. Otherwise compilation fail. Now this is okay. Compile it. It is fine. Similarly, in the interface, if I declare just int x, and it will be by default public, static, and final. We are not using that, even though if that will be public, static, and final. Compile and you will get the same error. See, it is saying error is expecting an assignment operator after x. Why? Because it is by default public, static, and final. So now let us initialize it with 101. Now compile, no errors. Okay. I'll keep it here only, but I'll put in a comment. I'm not using those, okay? Now in interface, this is by default static. Public, how you will prove? If you want to prove that as public, you need to use in different package. Then only you will come to know, right? I'm not going to do that. You try it. You try your own. Try, just write it like this and try in different package. If you can access it, it will be by default public. Okay. Static, how you will check? If it is a static, I can access it through the interface name in.x. If I am able to access, then it is okay. Means it is static by default. Compile, Okay, execute test 158. That is fine. This means what? It is by default static. Final, how will you prove? If I try to change it is equal to 99. Now it should give an error. It should say final variable cannot be reinitialized. Compile. Cannot assign a value to final variable x, means this is by default final. If you want to write, you can do that. Public static final. That is also okay. If you don't write, that is also fine. Remember, into y I am taking now 1 this. This is also by default public static and final. Remember, when you are writing an interface, in interface, if you just declare a variable, that will be by default public static and final. Because of that reason, it must be initialized in the same statement. Because in class, if it is public static and final, if we are not initializing, we have a chance to initialize that in a constructor, right? We can have a constructor, and inside the constructor we can initialize x is equal to 99. That is fine. Or we can take a static block, and inside the static block we can say x is equal to 99. Anything is fine. But both these members, constructors and, or what is the other option? Other option is use it in the same statement. These three options are there in a class to initialize variables. But from these three, these two members, constructors and blocks, are not allowed in interface. So we left only one option, and that is in the same statement. So variable must be initialized in the same statement. Okay. In interface, a variable must be, if you declare a variable, it will be by default public, static, and final. And it must be initialized in the same statement. Otherwise, not okay. Okay. And because it is static and final and public, you can use it with the interface name itself. You cannot reinitialize because it is final. Right. So this is the first member of the interface, variable. Any questions so far? No, right? So next is methods. In interface, you cannot have a method implementation. Say I am writing void show, and if I write the body, say this is I am writing the body inside the interface, compile, it is not okay. Compile. Interface abstract methods cannot have body. So you must declare that as till this, just signature. Okay, just signature. And it will be by default public and abstract. If you want, you can define those also. Public does not make any difference. It is same thing. Okay, it is same thing. So as of now, these two members, another next one, inner class. We'll see in the topic in inner class itself. Okay, this member we'll see in the inner class itself. So two members in the interface as of now, a variable which is public, static, and final, and an abstract method by default. It should not have a body. This is the difference between an abstract. Now, what is the difference between an abstract class and interface? What is the difference? Abstract class, ABC. This is abstract class. It can have a void show, implemented method. Okay, no problem. It can have a variable int x. It will not be public, static, and final. It can have a static variable into y. It can have a block. It can have void m, which will be abstract. Right. It can have constructor. These are the difference between interface and abstract class. So now if you notice, an abstract class can have something implemented also. Okay. Abstract class can have some implemented functionalities. but interface cannot have any implemented functionality, nothing. So interface is also called as fully abstract class. Okay, abstract class can have some abstract functionality which is unknown or incomplete, and can have some implemented functionalities also which can be used. But in case of interface, you cannot have anything implemented. Everything is abstract. Okay, because of this reason, interface is also called as fully abstract class. Fully abstract class. Fine, this is the difference between abstract class and interface. Now, how you will use this show then? You need to subclass. And how you will subclass? Class hello. What we did for class to implement or to subclass? Class some xyz extends abc, like this. And here we need to write the implementation which is abstract. Abstract implementation you have to write here. I'll put all these in comment. Okay, so for interface, when you are subclassing it, you need to use implements keyword. Okay, implements and I implements. Okay, now what are the abstract members are there in this? You need to implement. If you are not implementing, again the same concept comes. You need to declare this class as abstract. Otherwise, it is not compiled. So now let us compile once. Currently, we just written implements in. We have not implemented the abstract method show yet. Okay. Now let us compile this once. It is saying hello is not abstract and does not override the abstract method show from in, from interface. Okay, so what we can do to avoid that, we can just write abstract. That is fine. It will compile, but you cannot instantiate. Compile, okay, you cannot instantiate. But our intention is not that one. Our intention is to instantiate. To instantiate that, you need to override void show. Now again, when you are overriding, we have seen overriding rules. You cannot reduce the visibility. Okay, if you are writing here public or not writing, these are already there. Even if this is not there, you must write this as public. This method must be implemented as public. So currently we have implemented, but assume we have not used public yet. Check this, compile, it will say you reduce the visibility. Attempting to assign weaker access privilege, it was public. We have not mentioned here public, but it is saying you are reducing the visibility. So you have to implement here public. Okay. Remember, whatever abstract methods are there in interface, by default, those are public. When you are overriding in subclass, you must write that public, otherwise it is an error. And we know this is a rule of method overriding. So now print line and just say show method in hello class. Okay. Now hello class can be instantiated. Again, dynamic concept you can use. This is super type and you can use the reference variable. So I'll say here in and new hello, or you can say the hello type reference variable, that is also fine. In dot show. It will verify the signature in super type, call from the subtype. Compile and execute. Compile test 158. Okay, show hello. Okay, show hello, and this is from the variable which is public, static, and final by default. So that is interface. We have implemented this one. Assume it has another method void disp, by default public and abstract, and this is not implemented here yet. So what we have to do? We have to declare this as abstract. Okay. Now, or okay, if you don't want to declare that abstract, you need to implement the other one as well. You need to say here public void disp, and this is disp method in hello. If you call it here in.disp, compile and execute, compile fine, execute fine. Okay, multiple methods you can have. So interface is a fully abstract class, and it has to use implements, not extents. Okay, not extents. Simple, right? Nothing is there in it, nothing much. Next is, any doubt so far? No doubt, right? If no doubt, then come back to OOPS concept. We have discussed already that in Java, multiple inheritance is not allowed, right? So we have class A, and A is having two subclass, class B and class C. This is okay, right? This is not multiple inheritance. But if it is like this, A is a class A is having one superclass B, and A is having one another superclass C. Then the problem is this is not allowed in Java. Why not allowed? Because in constructor, default constructor, it has super keyword. Which super? Is it A super or B super? Because of this reason, multiple inheritance are not allowed in Java. But by using interface, you can do it. How? Say I have an interface A. This is interface now, not class. A interface. Okay. I have interface B interface, and class C. C is having B a super type, A also a super type. Means how it is, you are writing class C implements A comma B. A comma B. This is allowed in Java. Why allowed? Because it has super inside constructor. Inside constructor is a super constructor C. Now which super it has to go? Constructor interface does not have constructor. This is no constructor here, no constructor. This we already know. Interface does not have any constructor. So this super, where it goes then? This is actually, it has extends. See here, extends object, then implements A comma B. So it goes to object class default constructor. Because of this reason, using interface, multiple inheritance you can achieve in Java. Okay. Let us take an example. 159. I'll clean all this. So interface IN1, first interface. Currently nothing is there in it. Then interface IN2, nothing, empty. Class A implements IN1, IN2, nothing, no implementation. Just this. Let us check if this works fine or not. Test 159. Compile it. Java C test 159.java. It is okay, no problem. Okay, it is okay, no problem. Now by default it has A, right? A, and in that first statement is super. Where it goes? It is extends. Even if you don't write, okay, these are there. Object. It is like this. Compile it. It is fine. It is okay. Okay. It is fine. So it becomes like this. Super calls goes to object class default constructor. In interface, you don't have any constructor. So because of this reason, through interface, you can achieve multiple inheritance in Java. Now, assume I have another class, class B. And B is having B default constructor. Print line B default constructor. Now, this will have by default extends object, right? It will be like this. Object class is there. We are going to see object class in very details little later, okay? So B default constructor. Now, instead of object here, I'll write B. Now where the calls goes, it comes into B. From B, it goes to object. And in this, I will write this A default constructor. This is just to prove that from A it goes to B, from B it goes to object. If you want, you can write here a super like this, okay? Now, if we create an object of A, the output should be B default constructor and A default constructor, right? Create an object of A, A1, new. Compile till this and execute. Test 59. Java C. Execute, compiled. Test 159. This is okay. Okay. So this is how you can achieve multiple inheritance in Java. Next is, suppose in these two interface, I have void M1 by default public and abstract. In this, I have void M2. Now, M1 and M2 both is inherited to B through IN1 and IN2. Now, both the function M1 and M2, you have to override, or a class has to declare as abstract. Okay. So currently, I'll override both of them. You must use public. Okay. Public void M1. And you can write here M1 in A from IN1. Okay, this M2 similarly M2 in A from IN2, and I'll call IN1 and IN2 from here. A1 dot IN1, A1 dot IN2. Compile and execute. Oh, cannot find symbol. Not IN1, M1 and M2, right? M1, M2. Compile and execute. Right? This is fine. So if you are having multiple inheritance through interface, all the interface abstract method has to be implemented. Otherwise, it is an error. Now, assume scenario is this one implemented by somebody, and this is implemented by someone else. You are writing class A, implementing IN1 and IN2 both. But what these guys do, both designed a same abstract method name. Okay, both is giving M1 only. Now, what will you do? Both is giving M1. And you cannot write here M1 twice. It will say it is already used. M1 twice you cannot write. So in this scenario, you can implement only once, and this one has to suffice both of them. Okay, both the interface. Compile. Oh, the error is now for this one. This. Compile and execute. Fine. Okay, if this is the scenario. Mostly you will not get this type of scenario, but if it is in case, if it is like this, then you can have to do it this. Okay, so user define another type, which is interface. Enum and annotation we will see little later. Next. Okay, apart from these features of interface, from Java 8, you have so many other features in interface. Okay, from Java 8, so many other features are there in interface. We'll see those in Java 8 features separately. Okay, any questions so far? Any question on interface or dynamic dispatch? This is interface over. Nothing else. This is enough. Or assume another scenario is this is M2. Okay, this is M2 and interface 1 is having M1 and class B is having a method public void M2. Okay, and I'm saying here print line M2 method in. Now you see your class A extends B, implements interface 1 and interface 2. Interface 1 is having M1, interface 2 is having M2. M2 is not implemented in your interface. In your class, M2 is not implemented. But your class extends another class B where M2 method is there with the same name. Okay, so that is also inherited, right? This is also inherited in class A. But you see here, B class and interface has no relationship. Okay, no connection at all with B and interface. But since this is inherited to A, so this inherited M2 method should work for interface 2 M2 method. Even if you are not overriding now, this should work fine. Compile again. This is okay and okay. Okay. You notice this is a very interesting concept. Another class which is extending in B, which is extending B is having that method, and B class and interface is having no relationship. B is having the same method. Okay, so that has to work for interface 2 method. You don't need to implement again, but if you have a requirement to change the functionalities, then you must implement with your functionality. Okay. Okay, so this is interface, dynamic dispatch, abstract class, abstract method. And why multiple inheritance is allowed by using interface? Why not allowed using classes? Okay. Any question? You repeat this OOPS concept videos, you repeat multiple times, okay? Otherwise it will be difficult in our next part. Fine. If no question, we'll leave here today. Thanks. Thanks everyone. Bye-bye. We'll continue tomorrow.